kind of like reflexive. We could say DB or DC is congruent to itself because of the reflexive property. We said it was equilateral, so AC and BC are congruent. Do you see any side, side, side? Side, angle, side, angle. Well, now angle will work for similarity, but we're trying to do congruency. So you're on the right track. Huh? Angle, side, angle. Okay. Angle, side, angle would work. Do you see any more? Angle, side. Okay. And because this is a 90-degree triangles, we could also do hypotenuse leg. Okay. So any of those would work. Why is it that AD, down here at the bottom, and BD are congruent to each other? Well, they do share the same vertex. Give me more. Let me underline.
The line splits the two. I forget what it's called.
Okay, it's like the equilateral. I think it's a corollary or theorem.
No, what did we used to call when it split something in half?
An angle bisector.
Yeah, maybe.
Okay. We could also say CPC, TC, because they all line up in our congruent statement. So a little spiraling back there. So if we just look at one of the 30, 60, 90 triangles, we discovered a pattern to them in our exploration earlier this week. Let's see if I can. Oh, it's not going to show up. Okay, let me bring it up. The pattern was that if the short leg was X, oops, it went crazy. Then the hypotenuse is twice as much, and the long leg is the short leg times the square root of 3. Now we did that in our exploration using Pythagorean theorem, okay? We're not going to rehash why that is right now. You can go back and look at that later. But we're going to use this pattern, okay? Fill in the blanks. So when we look at them, and also one of the things to keep track of is which one's the short leg and which one's the long leg. The long leg is right next to the 30-degree angle. So I always try to remember that x root 3 is next to the 30-degree angle. That just seems to help me anchor myself as far as like what goes where. And I do know that it has to be a leg. I can't use it as the hypotenuse. All right, so let's do some examples using this formula. Oh, goodness, where'd it go? There we go. All right, so number 1, the hypotenuse is 34. What would the short leg have to be? If the hypotenuse is twice as big as the short leg. 17. So she just divided it by 2. And then our long leg is the short leg times the square root of 3. And I just kind of do this real quick check that my 30 and my radical 3 are kind of sitting close to each other. All right, number 2, the short leg's 9. What would the hypotenuse have to be? It's 2 times the short leg. 18. And the long leg is the short leg times the square root of 3. And I just do my real quick check, make sure 30 and the root 3 is kind of close to each other. All right, number 3, 66 is our hypotenuse. What would the short leg have to be?
33.
Okay, we got some more chiming in. Okay, and our long leg?
33.
Root 3. Okay. All right, so here's what I want you to do. You're going to do that 4, 5, and 6, which I think is on the back. 4, 5, and 6. And do that with your neighbor. You might have a new neighbor today. Introduce yourself. Pair and share, okay? And I'm going to star this one because this is a little more on the challenging side. Okay, Gabby sees what's wrong with it. All right, the 5 is supposed to have a radical 2 in it. That's what we said. But it doesn't. That's the problem. That's the challenging part. We're going to have to come up with what times the square root of 2 equals 5. Now, I don't know about you, but I can't do that mentally. Okay? That's not like mental math. So the first thing that we're going to do is we're going to match it up. Okay? And sometimes I highlight them or, you can squiggle it in. So these two match. They're supposed to match anyway. Then what we're going to do is we're going to make an equation. Because I don't know mentally what times the square root of 2 equals 5. But I could solve for it. So we need to solve for x. We need to know what times radical 2 is equal to 5. So how do we undo x times the square root of 2? What? Not multiply. Divide. So we're going to have to divide by the square root of 2 to both sides of our equals. But there is a slight problem because now we have a square root in the bottom of a fraction. At the beginning of this unit, we said we can't do that because it's bad form, right? So we have to multiply to rationalize it. So I'm going to multiply by this bottom radical. Multiplying by 1, so it doesn't change the value. It's just going to look a little on the different side. So if I go across and multiply 5 square root of 2 over the square root of 2 times the square root of 2 square root of 4. And what's the square root of 4? Which is just 2. So now the x part is 5 square root of 2 over 2. If I replace it back in my formula triangle, that's what each one of these legs are. So that's why we ended up at the beginning of the unit. Remember I said we got to know all these pre-skills first. We have to know how to rationalize and simplify square roots. This is why we had to learn how to rationalize. Okay. Now we can do something very similar with 30, 60, 90. I'm going to hold off and do that next week with you. Okay? So I'll kind of let that digest. I do have a little exit slip for you today.
Thank you.
And then I've got some papers to hand back.